This meeting is being recorded.
Okay, Cassidy? Is Cassidy here? Okay, Alejandro?
Here.
Liliana?
Here.
Lainey?
Here.
Romeo? Brenda?
Here.
Jasmine? Jade?
Here.
Valerie?
Here.
Edsel?
Here.
Monique? Or sorry, Joel? Monique? Salvador?
Here.
Caitlin?
Here.
Kayla? Romeo? Paola?
Here.
Ricardo?
Here.
Okay, sounds good. Okay, let's finish up chapter 11 today. Okay, the density curve and normal distribution. Okay, the curve has inflection points. Let's look at the standard normal curve here. Okay, so it says that it has inflection points at +1 and -1. Okay, those are just where it changes from going up to down, concave up to concave down. I'll bring this in a little bit more. So this is -1 standard deviation, +1 standard deviation. Okay, the total area under the curve is equal to 1. We covered that already. Total area. The area under the curve to the left of the mean, okay, is equal to 0.5. So half of the area is this way, and half of the area is that way. The graph tails off toward the horizontal axis on the left and the right. In addition, empirical rule holds. Okay, so now we want to convert between z-scores and areas. Okay, we want to compute a z-score if not given. Okay, z equals x minus mu over sigma. We want to draw a labeled and shaded normal curve with the given parameters. We want to look up computed z-scores in the z-score table. Okay, and I've given that to you. Okay, it's in the module if you don't have it. Okay, if the area is needed to the left of the z-score, okay, and to the left of the mean, the area is 0.1 minus the table value. We'll get to what this means in a little bit. Okay, so it says if the area is to the left of the z-score, okay, to the left of the z-score, then it's 0.5 minus the table value. Okay, so and we'll get to what the table value means, but if we want to the left of the z-score, like that, okay, then it's 0.5, it's half minus whatever that z-score is. Okay, to the right of the z-score and to the right of the mean, okay, it looks like this, then it's also 0.5 minus the table value. Okay, because this whole thing is half. The table value is going to give us this piece here. This is what the table value is going to give us right here. Okay, table value is going to give us here, but we're interested in the tail. So I have to subtract off 0.5 in order to get that tail. Okay, okay, 0.5 minus the table value. In between two scores, z1, z-score, find the table value for z2 okay, plus the table value for Z1 and add them together. To the left, so that would be between two scores. So we would get a table value. So say we want them between here and here. I get a table value here, table value here, and then I'll add it together. Okay, to the left of the Z-score, to the right of the mean. So say that we wanted this thing here. We wanted everything to the left of the Z-score. Oh, whatever. Sorry, it should be more like this. To the left of the Z-score, but it's to the right of the mean. So it looks like this. Okay, then what we would do is we would take 0.5 and we would add the table value. 0.5 plus the table value. Again, what's the table value going to give us? The table value is just going to give us this. And so we have to incorporate all of the area. Okay, and then the same thing on the other side. Okay, if we want this guy, then we would incorporate the table value, which is this guy here, and we would add 0.5 for the rest of the scores that we want. Okay, so let's go in and see how this works. Let's revisit example 9.15, where the standard deviation, the mean of the peanut butter prices was 0.26 and 3.68 respectively. Compute the area for a peanut jar costing less than $3. Okay, so first thing I like to do is always draw a diagram, draw a picture. Okay, always draw the picture. So let's see what's happening here. That's a bad picture. Okay, so where are we at with the mean here? The mean is $3. Or sorry, no, it's 368. It's 368. So where is $3 relative to that? Well, it's right here, $3. Now I need to know, am I going to go above $3 or below $3? Okay, so it says compute the area costing less than $3. So I really want this little area here. So what I have to do is I have to convert $3 to a z-score. Okay, and then I'm going to use the table to figure out what's this little area here. Now to get the tail, just this little tail, okay, we said that that was 0.5 minus the table value. Okay, so 0.5 minus the table value. So I just have to convert it to a z-score, look up in the table and subtract it from 0.5. Okay, so what's the z-score going to be for this thing? Get rid of this right now. Z equals x minus mu over sigma. Okay, so this is $3 minus 3.68 over 0.26. Okay, so this is going to be negative 0.68 over 0.26. What does that become? Negative 0.68 divided by 0.26 is 2.6. Yeah, 2.615. I'll say 2.615. So this is negative 2.615. That's the z-score. So that's what z is equal to. So now what I'm going to do is I'm going to look this up in my table. Okay. Okay, and then I'm going to see, well, whereabouts is the positive value? We always kind of absolute value this. So if I want the absolute value of z, this is 2.615. So I'm going to look up in the table, where is 2.615? Okay, so let's go to the table here. Okay, and the way we read the table is if I want 2.615, okay, it's really, I think it only will go to the hundredths place for the value that I'm looking at. So let's do 2.62. Okay, so I go all the way down to 2.6, and then this is going to be like 2.60, 2.61, 2.62, right? So I go all the way down to the 2.6. 2.6, and then I look over to this would be 2.60, this would be 2.61, this would be 2.62. So I look at this value here, it's 0.49560. Okay, so I'm going to grab this guy, 0.49560, I'm going to subtract him from 0.5. Okay, so subtract that one from 0.5. So I'm going to take, okay, 0.5 minus 0.49560, okay, and that's going to equal 0.5 minus 0.49560, and I get 0.044. 0.0044. Okay, and that was the area, okay, for a peanut butter costing less. So that's what that area is. That's 0.0044. That's that area there. That's the area. Okay, so pretty far away because the z-score was pretty far away. It was 2.6. It's almost, that's way less than 95%. Okay, remember, 2 standard deviations was 95% away from the mean. Okay, this is, okay, compute the area for peanut butter jar costing more than 4.25. Okay, so once again, draw a picture. Always draw a picture. We want 3.68. This time I'm looking at more than 4.25, 4.25. So again, that's the tail I'm still looking at. Okay. So again, I've got to compute a z-score. The z-score is going to be 4.25 minus 3.68 over 0.26. Okay. When I divide this, when I subtract and divide, I will end up with 2.192, 2.19. I'll just go out to the hundredths place. This is 2.19. Okay, so that's my z-score. So once again, I got to look it up because I want the tail. Whenever I'm looking for the tail, it's 0.5 minus the table value. Okay, so this is 0.5 minus the table value for 2.19. Okay, so what's the table value for 2.19? Okay, let's go up. Okay, 2.1, this is 0, 2.1. I think it's going to be all the way to the end here because this would have to be 9. Whoops, 2.1. Okay, 2.19, this would have to be this. Okay, because if I went 2.1, or if I went to a 0 again, I would be on the 2.20. Remember, these are the zeros. Okay, if you go to the very top, it should show a 0.9. So it's 2.19. So that's the value that I'm looking at, 0.4857. 0.4857. Okay, so let's subtract that, 0.5 minus 0.4857. 0.5 minus 0.4857. Okay, equals 0.0143. Okay, So that's that value. Okay. Okay. Compute the area for a peanut butter jar costing between $3 and 4.25. Okay. Well, we already know the z-scores for 3. Z for 3 is negative 2.615. Okay, and the z for 4.25 is, we got that, z was 2.19. I'm just going to put 2.62 and 2.19. Oops. Okay, so the table value for this, table value for 2.62 was 0.4956. Okay. And the table value for 4.25 was 0.4857. 0.4857. So I want to know what's the area between this $3.3 and 4.25. Well, I've got to include this area plus this area, okay? The area that would give me, okay? And we're always starting at the halfway mark, okay? We're always starting at the mean. And to go down from the mean, that would be an area of 0.4956. To go up from the mean here, okay, to 4.25, it would be an area of 0.4857. So all I'm going to do is add those numbers together. Bring this over. I'm going to go 0.4956 plus 0.4857 is 0.9813. Okay, so this is going to be 0.9813 is the area under that curve. Okay, let's calculate some probabilities that respond to z-square areas. Remember that we can look at the area as a probability, okay, or 100%. We can start thinking of these areas in terms of probabilities. Okay, so we can change them to percentages if we want to. Okay, so what is the probability that a randomly selected jar of peanut butter costs less than $3? Well, we knew what it was, less than $3. That's what this was. It was from part A above was 0.0044. If we change that to a probability, say the probability that X is less than $3, I got an extra zero there, less than $3, okay, is equal to, I can move this decimal over 2 and I would get 0.44%. That's the probability. Okay, what's the probability that a randomly selected peanut butter jar costs more than $4.25? Well, again, we already calculated for the more than, X is greater than $4.25, right? We found a z-score. We said z was equal to 4.25 over minus 3.68 over 0.26. We found a z-score. We calculated the z-score to be 2.19. Then we found a table value, and we did 0.5 minus the table value of 0.4857. 0.4857. Okay, and we came out with a value of 0.0143. Okay, 0.0413. So now I'm going to Okay, I'm going to move the decimal over twice here, and this becomes 1.43%. That's the probability of getting a jar of peanut butter that is more than $4.25. Okay. So very, very low probability. Okay, what is the probability of a randomly selected jar of peanut butter to cost between $3 and $4.25? Again, we would say that this is between $3 and X and $4.25. Okay. Now, if I change this to a Z-score, I just change the X to Z, and then it tells me, oh, that's a Z-score. Okay, so we want this between. Okay, what was my Z-score? Well, my Z-score was negative 2.62 and 2.19. So now the probability changes to a Z-score, and so we just find the areas of this, right? So the area from the middle down, okay, was my Z-score for 3. And then we use our table value of 0.0044. So this is 0.5 minus, no, this is just 0.4956. Okay, and then above to 4.25, this is 3, this is 4.25. So this area is going to be 0.4956, and this area, okay, is going to be 0.4857. Okay. Okay, and so we just add those together, and we say 0.4956 plus 0.4857. Okay, exactly the same thing we did before, which is 0.9813. Okay, so that, and so what is the probability of buying a jar of peanut butter between $3 and $4.25? The probability of purchasing a jar of peanut butter between $3 and $4.25 is 98.13%. We can write it as a percentage now. So you're 98% certain to buy a jar between $3 and $4.25. Okay, for a standard normal distribution, fine. Now this is a Z-score, so we don't have to find the Z-scores. They're just interested in finding, like, well, how do we find the Z-scores, right? How do we find the area or the probability under that curve? So again, always draw a picture. Okay, now what is the middle? What is the middle Z-score? What is in the middle here? The middle has a Z-score of what? Anybody remember? On a standard normal table, the middle has a Z-score of 0. It has a Z-score of 0. So keep that in mind. Okay, so where is 1.23? Well, this is, whenever you have Z-scores, you're talking about standard deviations. This would be like 1 standard deviation. This would be like 2 standard deviations. And so 1.23 would be here. Okay. So what do I want? I want everything below, okay, 1.23. Okay, so all I do is I go to the table and I see, well, what's 1.23? And then I add the bottom half to it, because the bottom half in the table is not included. So I got to take this 0.5 down here, and I've got to add to it my z-score, or not my z-score, that is my z-score, my table value for 1.23. So 0.5 plus 1.23. Let's go to the table. Okay. 1.23. Where's 1.23? So this is 1.20, 1.21, 1.22, 1.23. So this is 1.23 right there. So that's 0.39065. So 0.39065. This is very easy to add because we're just adding the two front digits. It's 0.890, and I'm going to round it to 7. Okay, so that's the probability that this is going to happen. So maybe I'll say we're 89.07% sure. Okay, in this case. Okay, what about this one? Z is greater than 2.07. So 2.07 and 0. Okay, always want to put the middle, put the mean. Okay, so 2.07. I want the tails this time. Okay, so how do we get the tails? Well, that's going to be 0.5 minus the table value. Okay, if I just want the tails, I'm going to look up 2.07, get that table value and subtract it from 0.5 this time. Okay, so let's look at our table value. The z-score is 2.07, so 2.07. 2.0, this is 0. Now remember, it starts with 0. The table starts with 0. 0, 1, 2, 3, 4, 5, 6, and 7. Okay, so the table value is right there, 4.8077. Okay, 0.5 minus 0.48077. Okay, which is going to give me 0.1923. Okay, so that's going to be, move the decimal over, that's going to be I'll say 1.9%. Okay, 1.9% on that one. Okay, now what about this one? Probability that we're between 2.76 and 1.96. Okay, so probability that we're between 2.96 or 2.76, negative 2.7 and 1.96. 6. Whew. Okay, zero's in the middle. What should this be? Let's take an educated guess here, right? Okay, so what would it be if it was between 2 and 2? Anybody make that connection between 2 and 2? What if we had a z-score between negative 2 and 2? What should my probability be? Somebody say something.